Hi everyone, I hope you still enjoy Hacktivity. If you are interested how you can hack Windows domains, then I'm sure that you are in the right room. Actually, this whole talk has nothing new. What I mean by this is that I just basically telling you what you can already find on the internet. But I do believe it will be still an interesting presentation. Just a quick question, how many of you have hacked any Windows domains where at the end you got domain admin privileges? Hands up. Okay, that's very good. So who am I? I don't really plan to spend too much time on these slides because you might have already seen this in the morning. So I do love creating offensive stuff. Let's talk about Windows domains, right? So in the very beginning, whenever there was no domain at all, what really happened that if there is a huge organization, for example, a university, and they have thousands of computers and thousands of students, then it's a total nightmare to administer who can access what. And if you want to do it locally, you basically have to hire just a team of IT guys who are constantly creating new users and removing old users. So there was really a need to make it a centralized database. And with this centralized database, you can list all the users which are in your domain, which are in your enterprise, and you can also put in this database all the data like who can access what. Like this user, he can use these workstations and those servers and can print and can access the web proxy, but the other user, he can also create new users or reset the passwords of the others, so you get the idea. So why domain admin? What is basically a domain admin privilege in a Windows domain? If someone has domain admin privileges, he or she can reset anyone's email password, access anyone's email, log on to anyone's computer, install software on that computer, access all the files, or create a new certificate authority, stuff like that. Which means that if you are an attacker and you gain domain admin privileges in a domain, you feel like this, right? It's always a pleasure to being a domain admin and owning a domain. Whenever attackers attack Windows domain, they have a certain goal in their mind, what they want to achieve. And usually, but not always, it is easy to achieve this task if they have already domain admin privileges, right? So if, for example, their target is the CEO email and what he communicated with all the others, then having a domain admin privilege is a very good step to access the CEO's email. And how do attackers gain domain admin privileges? Usually it's a pretty simple four-step. First, they have no privileges in the enterprise usually, so they should gain some user privilege in the Windows domain. After that, optionally, they need some local admin privileges, and from local admin they can escalate their privileges to domain admin, which means profit, right? Pretty easy. But how can you have user privileges in an environment where you don't have any privileges? I will talk about 3 different scenarios. The first scenario deals with an attacker who's on the internet. It's not physically nearby to your company. One of the best ways nowadays is just to send an Office macro file for the user, let him scare with like, oh, there is a 0-day warning because ransomware will attack you. To read more information, click enable macros, right? You wouldn't do that, right? Also, it was very, how could I say, used in the past that attackers exploited the browsers itself through vulnerabilities or exploited plugins like Java or Flash, or they targeted the Office installation itself. I think nowadays it's becoming less and less significant, but it's still important. One of the easiest ways to get access to remote Windows domain is just to ask the user and let him type in his username or password in a password box, which is called phishing. I think everyone knows this. I used to say that phishing is lame and it's not important, but I have to say I was wrong, because phishing was very effective 10 years ago. It is very effective nowadays, and I'm pretty sure it will be still effective 10 years from now. So this is really an attack you should really care about. If your attacker is already on your local network, they can try to hack stuff. For example, Tomcat application server is a famous old example where you scan the network, find the Tomcat, use some default credentials to log in. Now you are admin on Tomcat. Now you can deploy some applications, and now you can execute code on the server itself. GBoss GMX is basically the same. I have no idea what GBoss GMX is or how it works, but I only know that it is a very good way to gain domain admin privileges. And MSSQL was same, but only very, very old versions were vulnerable to attacks like this. If you're an attacker on the local area in the target company, you can also use Responder. If you don't know Responder, I will talk about this on the following slides. And last but not least, you can use any decent Windows exploits to exploit the Windows desktop or Windows servers. There was an old famous one which was used by the configure worm, if you remember that. And I do really hope that everyone who is here heard about the Eternal Blue exploit, which was patched this year. So what is Responder and how does it work? Responder is using these very obscure protocols, which I even don't want to say what it is. But you have to know that it is some Windows stuff on the network. That's all you need to understand. And whenever you start Responder, it's basically faking to the network that it is an SMB server, it is an MS SQL server, it is an HTTPS server, an LDAP server, FTP, POP3, IMAP, SMTP, VPAD. So it really acts like a student who knows the answer to everything. Me, I know, that's me, I know, right? And what really happens here, that the best way to use Responder is if you are in a man-in-the-middle scenario, like using ARP cache poisoning or something similar. And in this case, you can basically see all the traffic from the victim client, and whenever the victim client tries to authenticate to any of these services, your tool will respond to this and say, it's me, please authenticate to me. And what's really nice about this, that because the victim will authenticate to you, you can instantly grab all the hashes from the protocol, which you can use to crack it. But what happens if it's not that easy to crack these passwords because of those password policies and things like that? In that case, you can use a technique called SMB relay. Because what you can do here is that you man-in-the-middle connection and you man-in-the-middle the NTLM authentication protocol. So whenever the victim wants to access a resource, you forward this request to a server or something like that. When the server replies, OK, you can authenticate to me by this or that and with this data, then it is relayed back to the victim. And after completing the whole NTLM authentication, what happens that you, as an attacker, have basically access to the resource which the victim wanted to access. But this is only working when there is no server-side. The server is not authenticated by the client, right? Because if it's authenticated, you really cannot do this man-in-the-middle stuff. And if you ever administered Windows group policies, you know that SMB signing is basically handling this part. There is a third way how you can have user or local admin privileges if you have physical access to one of the machines you want to attack. How many of you have know or used the SetHC trick? Hands up. OK. I use it usually whenever I visit parents, grandparents, and they tell me that, oh, I forgot my password, I cannot log into Windows anymore. And it is a trick that SetHC runs on the Windows logon prompt whenever you hit the Shift key 3 times, and it's popping up basically the accessibility features or something like that. So if you have access to this computer, for example, you can boot from another media or something similar, and the disk is not encrypted, you can replace sethc.exe with cmd.exe, which means whenever you hit Shift 3 times, then the cmd.exe will pop up. So you already have a command shell with system privileges, which is nice. Another attack is that you boot a tool, something like offcrack or something else, which can extract the local user hashes from the machine. And after that, you can use something like rainbow tables to crack the passwords. But it turns out that nowadays even rainbow tables are slow. And if you have a really badass computer with a lot of GPU, then you can have better results with that. What does this mean? I think password cracking on conferences was hip and fancy like 5 years ago, 10 years ago. Nowadays, nobody is talking about this because it's old stuff, and we don't care about old stuff. But if you do the math, it turns out that password cracking is a huge issue nowadays. Let's say you have $5,000 to spend on an awesome machine, something like this. And this machine can basically try to crack NTLM hashes with a speed of 208 gigahash per second. Yeah, it doesn't mean anything to anyone, I think, these numbers. So let's do the math. Let's say that the user is using a password which has lowercase characters, uppercase characters, digits. It is 10 character long, not 8, 10 character long. And it's totally random. There is no pattern, no word list. It's not password 1 and not welcome 12 or stuff like that. It's totally random. What do you think? How much time do we need to crack these kind of passwords? Yes. On average, you can crack a password like this in 22 days, which means maximum 44 days. This is a totally random 10-character password. Pretty scary, I would say. OK, now that we, as an attacker, have user privileges on the network, we should gain local admin. Why do we need this? And how do we do this? I was told in the past that, for example, Windows XP is so insecure that he's pretty sure that it can be attacked and the user can gain admin privileges instantly. Turned out that by default, if XP is fully patched and there are no services, stuff like that, which are vulnerable, it's not that easy to gain administrator-level privileges. For example, I'm sure you all heard about Stuxnet. Stuxnet was attacking Windows XP machines, and whenever it was running as a user, it used zero-day exploits to gain administrator-level privileges from the user privileges. In an enterprise, you can find some in-house developed services, and usually these are a very good way to gain your privileges from user to local admin, because usually the privileges set on this service are pretty bad. What this means that usually anyone can stop or start this service, and anyone can replace the binary under the service, and the service runs with system privileges. So what does it mean? If an attacker stops the service, replaces the binary, starts the service, his code will execute in memory with system privileges. Sometimes attackers are greeted with the UAC prompts. So that's what limits their ability to gain local admin privileges. And I have seen a very nice example in one of malware samples. What it really did is that it dropped a Flash Player update next to itself. And the Flash Player update started and asked the user with this UAC prompt that, hey, I'm Flash Player, please update me. And if you checked it, it was really, really a Flash Player. But due to DLL hijacking techniques, if you clicked OK, it was not just the Flash Player, but the malware as well, which gained the admin level privileges. OK, what do? You click cancel, right? Funny thing was that it was an endless prompt. So if the user clicked cancel, it popped up again. User clicked cancel, it popped up again. And it was so fast that when I tried, the only way to get out of this loop was the power off button to shut down physically the machine. There was no other way to get rid of this UAC prompt. Last but not least, you can always try to find credentials in clear text. For example, you check for passwords.txt on the desktop, or you go for a network share, which has domain controller backup.zip or something like that. And from this, you can always get very interesting data. Sometimes you need to escalate your privileges from local admin to local admin. What does it really mean? It's not that good if you have local admin privileges on a user desktop, because it's a lot better if you have local admin privileges on a desktop which is already used by an admin, right? So you have to move laterally between the computers and get admin privileges on other machines as well. So let's talk about a little bit pass the hash and the pass the ticket technique. How many of you guys heard about pass the hash? Okay, all right, it's like 50%. So what is pass the hash? Whenever you use your Windows computer, it will authenticate to services in the background instantly. If you access a file share, you don't have to type your passwords again because you are already logged into the domain. If you are using a web proxy and the web proxy wants to authenticate you so they can log who visited which website, then you don't have to authenticate to this web proxy every time it downloads a new image, for example. So let's say that you want to check index.hu. I'm sure that it will be a pain in the ass to type your passwords like 300 times just to get authenticated to the proxy every time, right? So what has to be done that in Windows, there has to be a certain memory area which already holds your credentials, which can be used to authenticate to these services. And this is what pass the hash is about, that you as an attacker extract this hash from the memory, you inject it into your system or into your process space, and now you can use this hash to authenticate to the services with the same privileges as the user originally had. As I mentioned, usually it's a hash in the memory itself, but in older versions of Windows, I'm sure Windows 7 is vulnerable to this. Sometimes it's not just your hash which is stored in the memory, but sometimes it's your clear text password as well, which is pretty scary because no matter how long or how complex it is, it's already clear text in the memory. Okay, so now the attacker has local admin privileges. What can he do with this? Let's try to authenticate with this local admin hash to another computer, probably to one where a domain admin is already logged in. In Windows 7 and above, there was a new policy applied which prevents the pass the hash attacks by default. And this policy says that if a machine is already connected to a domain and remote user tries to log in to this machine with local admin privileges and with this hash, then it's denied. And some people call this feature some like remote UAC. The long Microsoft name is Local Account Token Filter Policy. And if you are a pen tester, this makes you a really sad panda because you cannot move laterally as easily as you used to be before. But as it is the case with every security policy, sometimes it breaks stuff, and sometimes IT administrator tools break because of this policy, so they turn it off. So you might be still lucky that you can use pass the hash this way. So the next question is, if you are the attacker, how do you find the juicy targets? How do you find those machines where you have login credentials already with pass the hash or something similar, and where a domain administrator is already logged in? The old school stuff was that you use some command line built-in Microsoft query tools to query the domain, like ask what are the names of the domain admins, so which users are in this group and stuff like that. But this was pretty slow and didn't scale really well. So after Microsoft introduced PowerShell, there were some very nice tools written in PowerShell which you can use to query the domain for all these different type of questions you are interested in. But luckily, like 2 years ago, some guys wrote this awesome tool called Bloodhound, which basically automates all these tasks which you had to do manually before. So what is Bloodhound? Bloodhound runs in a Windows domain with user privileges. And what's really interesting that with user privileges, you can ask the following questions and you will get the answer from the domain. You can ask who is logged in where. You can ask who can administer which machines. And you can ask who is in which groups. And if you have the answers to these 3 questions, you know basically everything about the domain which you need to hack the domain itself. It's a graphical application, and in this screenshot what you can see that there was a question that if I as an attacker have access to this machine, to this workstation 2, how can I move laterally so I will be able to access the Josh Dev computer? And when you type this query into the tool, it will check the backend database with all the answers it already got from the domain. And it can tell you, oh, that's nice, because the Wattahog user is already logged in to this workstation, and this user can log in to the file server with admin privileges. And it's nice because on the file server there is an administrator logged in, and this administrator can access the Josh Dev computer because it's already a domain administrator. This is just a very simple test lab scenario. So if you do it by hand, you can come to the same conclusion. But if the whole environment is a little bit more complex, then a tool like this can help you. And what you can see on this screenshot, that if you have, for example, a different domain for external users, and they have some very limited access on your whole environment, from these external domain users, what path the attacker has to reach domain admin privileges. And if you try to do this by hand during a 1-week engagement, maybe you can find 1 or 2 paths how you can do this. But with this tool, you can show your client that these are all the different paths which an attacker can use to reach domain admin privileges in your system. And I find it really cool, and I think Archer thinks this is very cool as well. And what is Pass the Ticket? The Pass the Hash attack is about NTLM authentication, and sometimes it's not NTLM what is used in a Windows domain, but a Kerberos protocol. These are some totally different protocols in the way how it works, but from an attacker point of view, they are the same, because both pass the hash and both in NTLM and both pass the ticket for Kerberos, there is something in the memory which the attacker can grab and reuse it to authenticate to other services. Right. So what happens if the attacker has local admin privileges on a machine where the domain admin is already logged on? You can guess it's basically game over, because the attacker can extract the hashes or the ticket from the domain admin. The attacker can authenticate to a domain controller, and he pawns basically all the domain. Sometimes attackers, what they do in this stage, that they log into a domain controller, they upload some tools to the domain controller, run it, and they will be able to extract for all the users all the password hashes. I don't think this is a good idea if you are into sneaky hacking. What's a lot better idea is that you basically create a new domain controller on the network, and because you have domain admin privileges, you can join this domain controller to the current domain. All the information will be synced to your domain controller. You shut it offline, bring it home, do the cracking at home. It's much better. Regarding pass the hash, I have seen a lot of times that people say, we don't worry about pass the hash. We are much better than this. We have smart cards. We have RSA-based one-time password authentications. We are covered. The problem is that it's not true. Because at the back end, what really happens that if you use smart card or use one-time passwords for logins in a Windows domain, in the background, it will just generate a random anti-LM hash, and that will be your basically fake password. And because the whole Windows is built on top of anti-LM, you can still use this anti-LM hash for pass the hashes. So pass the hash and pass the ticket completely bypasses smart cards and OTPs in Windows environment. Also, a lot of people say that, oh, our admins, they have 20 characters long passwords, so we are protected. These are the people who didn't listen to this presentation, because if you use pass the hash, you never ever have to try to crack the password itself. You just use the hash, so it's no matter how long, how complex it is. There is a very nice trick. If you already have user privileges on the network, how you can gain admin or domain admin privileges. And it's called the GPP syswall trick. Syswall is like GBoss GMX to me. I have no idea what it is or how it works, but I do know that it is one of the best ways to gain domain admin privileges in a network. Whenever you are already logged into a Windows domain and you open Explorer exe and put //domains/syswall/your domain name/policies, then you will be greeted with some files and directories and stuff like that. And it basically contains information which is needed for the Windows to be a part of Windows domains. So all the group policies and stuff like that is there. In the very old days, this syswall was used for scripts which were running boot time or periodically on the client machines. These scripts usually had to run with local admin privileges, but when the user logged in, the user didn't have any local admin privileges, so there were clear text usernames and passwords in these scripts, which was very, very bad because anyone could access these passwords. So Microsoft bought a technology which was able to hide this, and now they basically encrypted these admin passwords in these scripts, which was pretty nice. But if you are into reversing, you know that at some point in time, this password has to be in the memory in a clear text, so it can be used for authentication, right? So if you are a reverse engineer, or you can give enough pizza for a reverse engineer, he or she will be able to get the key which was used to encrypt this password from the memory, right? Luckily, Microsoft was kind enough to publish this static key on their website, so you don't have to buy pizza or do the reverse engineering yourself. You can just download this key, and on the bottom you can see this encrypted password. And if you use any crypto library, basically you have the encrypted text, you have the key, you combine those together, and you get the clear text passwords. Easy peasy, right? Like 15 or 20 years ago, doing this whole domain admin hacking, it was more of an art than a science. Nowadays, it's more of a do this, that, and you will get domain admin. So it's now a well-documented procedure what you can do to gain domain admin privileges. And if it's not an art anymore, it means that someone can basically write a software to do this task, right? Right. So someone created this tool, and it's published on the internet. It's called DevStar. I think it's a pretty cool name for this project. And this DevStar tool, in order to run this, you need a PowerShell Empire session. How many of you guys have used PowerShell Empire? Okay, it's pretty cool stuff. So what it really is that you basically run some PowerShell commands on the victim machine, and it will create a reverse shell to your attacker machine, and from now on you have a PowerShell session to this machine, and you can do anything which you can do with PowerShell. So if you have this PowerShell Empire session to a victim machine, you just start DevStar, and it will do all the job I mentioned to you by its own. On the screenshot, what you can see that it queried the whole domain, and now it knows that what kind of domain admins are in the network, what are the domain controllers, who is logged in where, stuff like that. After this, it tries to spread laterally, and infect all the machines it can. And after a while, it will basically log in to a machine which has already a domain admin user logged in. And whenever it finds this machine where the domain admin is logged in, you get back a PowerShell session with domain admin credentials. So that's it. What does it mean for penetration testers? I think these tools are awesome because you, as a penetration tester, don't have to focus on the boring scriptable stuff anymore. You run this, you gain your domain admin privileges, you also run the Bloodhound tool, and you can show the client that these are the different ways how attackers can gain domain admin privileges in your network. And if you do this in one day, the rest of the week is for you to do the art of domain admin hacking. And this is where a penetration tester should really focus, and this is where the added value is, I think. There was also a very nice vulnerability in the Windows domain environment in 2014. And how this attack really worked, it's pretty interesting because whenever Microsoft found this issue, it was already exploited in the wild. And the attack worked like that. The attacker has already user privileges in the Windows domain. It asks for a Kerberos ticket. Locally, the attacker rewrites the Kerberos ticket and writes into the ticket, hey, I'm not a user, I'm a domain admin. The attacker sends back the ticket, to authenticate to any services, and he's domain admin. I mean, how cool is that, right? Unfortunately, it's now, I think, patched in almost all enterprises. But this Gavin guy took a very good explanation of what really happened here, that you go online, you order a flight ticket, you print at home, and you really don't want to sit on 23A because who wants to do that? You just write on the ticket, I'm the pilot, right? You go to the airport, you use your ticket, and you can fly the whole airplane. Really, really cool attack. Now let's talk a little bit of defense, because defense is as important as offense. One of the first things you can do is to use unique local admin passwords on every machine. And whenever I say this to people, they just freak out. No, we cannot do that. But turns out you can be creative, and you don't have to shoot yourself in the leg with this. For example, let's say you choose a fixed password, and after the fixed password, you put the machine name, which is unique. You concatenate these two together, and now you have unique passwords on all the machines. And this is pretty cool, because if it's long enough and the original password was complex enough, so it cannot be cracked, now because it's unique on every machine, you cannot pass the hash between the machines. Previously, you had to do this manually, but now Microsoft provides a tool called Microsoft Local Administrator Password Solution to solve this exact problem. You also have to separate your domain admin workstations from the rest of the workstations, from both on a network level, so you have to build a great firewall or something, or you have to definitely separate it physically. And I think it's always a good idea that if there is a domain admin who is doing his daily task, this domain admin privilege is never used on his desktop workstation. So he doesn't use this for checking emails, doesn't use this to browse the internet. If the domain admin uses his domain admin credentials only to log into servers, and from servers he will be able to administer everything, that's the way to do it. As already mentioned, if you turn on SMB signing in your network, then you can break the SMB relaying attacks. And there is a Microsoft tool called ATE, which I find pretty cool. And what is especially cool that they wrote like 20 or 30 pages long PDF, which explains to you that if you do this kind of attack, what I already mentioned during this presentation, at which step, how Microsoft ATE can detect this attack, which is awesome. But as it turns out, it's not a silver bullet. As you know, there is no silver bullet. So it's only useful if the attack involves a domain controller. And there's a guy called Nikhil Mittal, and he posted like in 4 weeks, I don't know, like 20 or 30 different type of bypasses, how you can evade this solution. So this is not a silver bullet, but still you can gain an awful lot of knowledge from these articles if you are into defense and offense. So that's all, folks. That's all I wanted to share with you. Thank you for your attention.